In this episode of Remote College Algebra, we're going to be talking about lines. And I'll make the point that we're in math class and we're not in art class. And when you're in art class, you might hear about a curved line drawn, but in math class, lines are straight. Here's a parabola, for example, that's not a line, and the slope is different at every single point. Sometimes the slope is negative, sometimes the slope is zero, sometimes the slope is positive, sometimes it's steep, sometimes it's not so steep. But for a line, the slope stays the same at every single point. And the slope shows up in its formula as the coefficient of your input. The other important part of the formula we often will refer to as b, because we'll read this off as y equals m for the slope, times x for your input, plus b. What we mean by that is it's the y coordinate of the point where you're crossing the y-axis. It's the y-intercept value. So in this example, Joe's starting salary is $30,000. So when his sales are zero, his starting salary is $30,000. The y-intercept can be considered the starting point of the line. And in this case, it makes really good sense. If he sells nothing, his base salary is $30,000. That's his starting point. And then every time he sells $1, he gets 8 cents of that $1. It makes a little more sense in this case to talk about him selling thousands of dollars. And so if he sold $40,000 worth of his company's product, his overall compensation would be the beginning amount of $30,000 plus 8% commission on the $40,000. And that would give us $33,200. So again, y equals mx plus b. The b is the value at which you're hitting the y-axis, or the y-coordinate of the y-intercept, and the m is the slope, and it's the rate. It's the rate at which y changes as you change x. Looking at another example, suppose I go out running and I run at 1 mile per 8 minutes, or in other words, 8-minute miles, then a formula that reports back how far I've gone is y equals 1/8 x. So notice my starting point, when I've run 0 minutes, I've gone 0 miles. So I go through the origin in this case. So b does not show up in the formula because b is 0. If you wanted to, you could write plus 0, but you really wouldn't have to, so we might as well just leave the equation simplified as y equals 1/8 times x. So every time I run 8 minutes, 8 minutes is my input, okay? So every time I run 8 minutes, I increase my distance by 1 mile. So if I run 8 minutes, I've gone 1 mile. If I run 8 more minutes for 16 minutes, I've gone 2 miles. If I run 8 more minutes for 24 minutes, my distance is 3 miles. If I run 8 more minutes, or 32 minutes total, my distance is 4 miles. And if I've run 40 minutes, I've gone a total distance of 5 miles. If I've run a whole hour, then I've run 7.5 miles. So 7.5 would be 1/8 times 60. 1/8 times 60 gives me 7.5. So here my rate, or my slope, is 1/8, meaning every time I increase my input of minutes by 8 minutes, I increase my distance by 1 mile. And my y-intercept was 0 because when I start off, I've run 0 miles. So it goes right through the origin. This is kind of a famous example in which this real data collected showed us this pattern, that the number of times crickets chirp is associated with the temperature in a very tight linear form. So X in this case is counting number of cricket chirps per 10 seconds, and Y is the temperature in degrees Fahrenheit. In this case, the B, the Y equals mx plus B, is still the Y-intercept, it always is, and it's 40. That means that when there are no cricket chirps, the temperature would be 40 degrees Fahrenheit. And then the slope, 1.39, is telling us how much the temperature is increasing for each additional chirp of crickets that we hear per 10 seconds. Now, in this case, that Y-intercept value doesn't necessarily make a lot of sense. At 40 degrees, it's probably too cold for the crickets to really be active at all. And at some point in time, when it's very, very cold, there are certainly no crickets out. And so X equaling 0 would be associated with a whole lot of different temperatures. So this is the linear relationship, but it makes much more sense to look at it on an interval for which the data was collected. So the data was collected when it was warmer, and the lowest temperature that really showed up in the data was around 70 degrees, high 60 degrees. And then the lowest chirps that was in the data was around 20. So it makes more sense to follow this pattern for a restricted domain that matches the data that was collected. The slope still means the same thing. Every time you counted one more chirp per 10 seconds, it was highly correlated with the temperature increasing by 1.39 degrees Fahrenheit. So at 20 chirps per 10 seconds, the temperature will be pretty close to 67.8 degrees. If you counted 21 chirps per 10 seconds, that average temperature would go up by 1.39, and in this case be 69.19 degrees. So here, the 40 kind of sets, it certainly is an important part of the line, but it doesn't really make sense to interpret it. However, the slope still has a very useful interpretation. Now let's look at how to find the equation of a line. So here I have 2 points, -6, 10, and 10, 4 is my other point, and I've connected them with a straight line, so there's a consistent pace to move from this point of -6, 10 to this point of 10, 4. So when I find the equation, and I'm all finished with the equation, it'll be of the form y equals mx plus b. Let us first find the slope. So to write the equation, I'm going to need the slope, I'm going to need the y-intercept. So I need to find those two things somehow. And depending on what information you're given, you can find them all kinds of different ways. Sometimes you could just see the y-intercept very clearly on the graph. Here I can tell it's between 5 and 10, but I'm not quite sure exactly what value between 5 and 10. So that is why I'm choosing first to find the slope. So notice this point has a y value of 10, and if I use this other definitely known point and I move from that point to this point, my y value goes down from 10 to 4. If I decrease from 10 to 4, that is a decrease of 6. So 1, 2, 3, 4, 5, 6. I've gone down 6 spaces. If I go from x -6 to x 10, I increase by 16 spaces. I go 6 spaces just to get to 0, and then I go 10 more spaces to get to 10. So this is a decrease of 6. This is an increase of 16. So my slope is the change in the y's divided by the change in the x's. If you don't have a graph handy and it's not so easy to just sort of see the differences, you always can, just do the computation. I take one y value and I subtract the other y value, and then I consistently work with those same x's. So if I took 10 minus 4, I need to take -6 minus 10, and that would give me 6 over -16, which is still the same thing that I have over here. Or if I took 4 minus 10, then I would have to take 10 minus -6, which would give me -6 in the numerator and +16 in the denominator. Notice they both give me the same slope. So in general, what I'm doing here is I'm finding the difference between two y values and dividing that by the difference of the x values. And who is 1 and who is 2 doesn't matter. What does matter is once you've chosen a particular point to be y1, its x value has to be the first number in your difference in the denominator. Otherwise, your slope will be the opposite of what it really should be. If you accidentally mix that up, you can easily tell that the slope is negative or positive. I can tell this slope is negative because as my x values were increasing, my y was going downhill. If I was on my bicycle, I would be going down this hill. So I can tell that this is a negative slope. And that kind of helps me double check if I've accidentally flipped around the differences. Okay, so that's our slope. We need to find our y-intercept value. And I'm going to do that by picking one of my points. It doesn't matter which point. I think I'll pick this point, 10, 4, because the values are positive. So -6 divided by 16 times 10, because 10's the x, plus b. If b is the correct b, I should get 4 for the y. Otherwise, my formula doesn't work, and it's not the formula of this particular line. So cleaning up this arithmetic here, let's see, I will get -60 over 16, but we can reduce that even more. Let's see, they're both they're both even. They actually 4 goes into both of them, so I'll divide the numerator by 4, I'll divide the denominator by 4, and then b will be 4 plus 15/4. Okay, I'm solving for b, so I want to cancel out the -15/4 being added to it. So I add 15/4 to both sides, and I end up with 4 plus 15/4. And if I want to keep everything in fraction form, let's see, that would be 16/4 plus 15/4 will be 31/4. So again, my equation's not all clean numbers. I mean, the math doesn't change just because the numbers aren't clean. You still do the same thing. So here we get a slope of -6 over 16. I think I will reduce that, and so that'll be -3 over 8, and then the b is 31/4. So that's the equation of the line that goes through those 2 points. Now, especially when one's a little bit messy like this and you want to check, take the other point that you didn't work with and plug it in and see if it works. So what I mean by that is we need to get out 10 when we plug in -6. So let's see if we do. So negative times negative is positive, and that would be 18 over 8 plus 31 over 4. And 18 over 8 reduces to 9 over 4. And 9 plus 31 is 40. And guess what 40 divided by 4 is? It is 10. So yay, we found our line correctly, because when we plug in the other point, it works out. And I could double check the arithmetic, but when we plug this point in, we should get that it also works out. Okay, let's do another example. Okay, so we're trying to find the equation of our line y equals mx plus b. And once again, sometimes you can tell what the b is right away. Notice in our last example we saw that it was between 5 and 10. We got 31/4, so 4 divides into 32 evenly at 8, so this is 7 point something, so that makes sense. It's, you know, kind of right in between 5 and 10. In this case, same thing. I can tell it's a little bit less than 2, but I don't know exactly what it is. So I cannot tell exactly what the b is, therefore I'm going to find the slope first. And so I'm going to find the difference between the y's. Now in this case, my y's are, you know, a little bit messier numbers, so I will formally write down y1 minus y2 over x1 minus x2. Notice I started with this y in the numerator, so its x has to be the first value in the difference in the denominator. And let's see here, 6 halves is 3. So in the numerator I have 6 halves minus 13 halves, and then 10 will be 30 thirds. And 6 halves minus 13 halves is negative 7 halves. And 8 thirds minus 30 thirds is negative 22 thirds. So cleaning that up, remember when you are dividing, it's the same as multiplying by the reciprocal. A negative times a negative will give me a positive, and 7 times 3 is 21, and 2 times 22 is 44. So my slope is 21/44. Now to find the b, pick one of the points. It doesn't matter which one you pick. I think I'll pick this one. So 21/44 multiplies 10, because 10's my x, then plus whatever the correct y-intercept value is should give me 13 halves. Otherwise, it's not the correct equation of the line. So cleaning this up, let's see, 44 is even, and 10 is even. So 21 times 5 will be 105, and then 22 times 1 is 22. Alright, so then b will be 13 halves minus that 105/22. And if I multiply 13 times 11, I get 143. And 143 minus 105/22 is 38/22. And if I reduce that, let's see, 38 is even, and it gives me 19, so I get 19/11ths. So let's see if that works. So we have 21/44 was our slope. And if I multiply that by 8 thirds, and then I add 19/11ths, I get 3. So 8 thirds times my slope of 21/44. So again, this is x, this is m. And then if I add 19/11, which I think is the b, I end up getting 3. It checks. So when I plug in 8 thirds, I get out 3. So y equals 21/44x plus 19/11. That's the equation of the line. Again, it's not a clean equation, but the same process works whether you have clean numbers or not so clean numbers. So in the example, I would rather do some that are a little messy to, you know, help you, you know, with some of the messier arithmetic, and then the ones that are nice and clean, you probably aren't going to have any trouble with those. Alright, so that was 2 examples of how to find the equation of a line. Notice this one had a positive slope. As x increases, y increases. So x goes up, y goes up, means you have a positive slope. And when x went up, y went down, that meant you had a negative slope. And the process is the same. You're trying to fill in y equals mx plus b, and usually you're going to find the slope first and then reason out the b from there. If you have horizontal and vertical lines, there's not a whole lot of work into finding their equations. A horizontal line is horizontal because y is always the same thing. So for example here, we have y equals 8. On this line, y is always 8, so that's the equation. Notice the slope is 0. So on any horizontal line, the slope is 0. So there is no x term because it would have 0 times x plus b, and the b is going to be the same y for every point on the line. This line would be y equals -2 because all of the y's are at -2. This is the x-axis, and its equation is y equals 0 because all the y's are 0. Now, if your line's vertical, then x is the same number. That's what makes it vertical. So for example, here it looks like we have x is equal to 4. All the x's on that line are 4. So we're just going to write the equation x equals 4. Here we have, well, looks like 11, 12, 13. So x is equal to 13 everywhere on that line. And the y-axis, x is always 0 on the y-axis, so that's its equation. So again, horizontal and vertical lines have equations. You do write the equation for a horizontal line and a vertical line, but there's much less work involved. You just need to identify what do all the y's stay for horizontal, what do all the x's stay for vertical. Now, lines are parallel if they have the same slope. And if you think about it, that means that they stay at the same pace, and if they stay at the same pace, they're never going to intersect in their plane. So I'm going back to my example about running, and let's say I'm in a race, and at time 0, I haven't run any miles, and so my y should be 0. My rate is 1/8. Let's say we have some cheater that jumped in at mile 5, then at time 0, their mile is already starting at 5. And if they have the same rate as I do, I will never catch up to them. My distance will always be behind theirs because they jumped in line. Hopefully some camera will have caught them jumping in and they will get publicly shamed and so forth. But in this case, my y-intercept value was 0, their y-intercept value was 5. Again, it's telling me what my distance is at time 0. Our slopes or our paces are the same. That's what. If you're trying to find the equation of a line that's parallel to another one, you're still trying to find the form y equals mx plus b, and as I stated earlier, you find m and you find b with whatever information you're given. So if you're given that you want your line to be parallel to another line, and that line has slope 3/5, you're automatically given the slope. You don't have to do any work. Your slope should be 3/5. So you're then going to fill in y equals 3/5 x plus b. And if we wanted our line to go through the point 10, 10, then I would plug 10 in for x and 10 in for y, and I would do the arithmetic. So 5 divides into 10, leaving me 2. 3 times 2 is 6. Solving for b, taking 10, subtracting 6, you get 4. So the equation of the parallel line that goes through 10, 10 would have slope 3/5 and a y-intercept value of 4. And notice if I connect the point 0, 4 with 10, 10, I can tell that line is parallel to the one that we started with. Now, perpendicular lines form a 90-degree angle. That's what perpendicular means. And notice when my line has a positive slope, a line perpendicular to it is going to have a negative slope. Not only that, but when you have, so here my slope is 3/4. So that means when I go over 1, 2, 3, 4, I go up 1, 2, 3 to get to another point on the line, or any ratio that's equivalent to 3/4. So I mean, I could go over 1 and go up 0.75. I would also land on a point on the line. So over 4, up 3. To be perpendicular, then if I go over 1, 2, 3, I'm going to end up going down 1, 2, 3, 4. So my slope is the reciprocal. I'm now going over the same number of spaces that I went up or down, and I'm going down the same number of spaces that I went sideways. So in this case, one of them has to be negative. The y, appears to be negative when we move in the direction that I moved. So I also automatically get my slope when I'm looking for a line that is perpendicular to another line. The slope is going to be the opposite sign. If this slope is positive, the perpendicular slope will be negative. And if this slope is 3/4, the perpendicular slope will be negative 4/3. So I know that my equation is y equals negative 4/3 x, and then plus a y-intercept value. And in this case, it looks like my y-intercept value is 6. I'm not officially given any particular point. And so if I look at the y-axis, it looks like I'm crossing over at 6. So I would finish off the equation, y equals negative 4/3 x,
not negative 4/3 x plus 6.
Is the line that is perpendicular to this line. Now this negative 4/3 x plus 6 is perpendicular to any line whose slope is 3/4. In order for lines to be perpendicular, their slopes have to be opposite and reciprocals. So the slope of one line is equal to -1 times the reciprocal of the other one. So if we had an example, so notice I have that same line I was working with before, but this time we want a perpendicular line to this line going through the point 10, 10. So we're still going to go through that same point, but we're going to find a line perpendicular to it. So I know that my slope should be negative 5/3 because the slope should be the opposite and the opposite sign and the reciprocal. So then I want to find b, and so I will plug in my known x of 10, and I should get out 10. And if I do that arithmetic, I get negative 50/3 plus b is equal to 10. And then 10 plus 50/3 will equal b, because I'm trying to get b by itself, so I'll add to cancel the negative 50/3. And 10 is 30/3. And if I add 30/3 to 50/3, sorry, I was getting ahead of myself there, we get 80/3. So 80/3 is my b, which, by the way, like 3 goes into, I don't know, 80, like 20 something times, 26 times, so 26.67. So I actually am not going to see my b on my graph here. But if I try to make a line perpendicular to this one, so I'm carefully trying to line it up so it's perpendicular. There we go. And I could see that I'm heading off in the direction where if I was going to cross at 26 something, that would make sense. Okay, So my perpendicular line would be y equals negative 5/3 x and then plus 80/3. Alright, so that's an overview of pretty much all the important things about equations of lines. And you know, you're going to fill in m for slope and b, and depending on what information you're given, you might find them by just picking the b off the graph, or you might you know, have to reason it out. Same thing with the slope. You might be just given information directly, like in the problem about the commission or the problem about running. We kind of were given the slope. I was given the slope with my rate of running, and I was given the slope in the commission problem by being told that he earns an 8% commission. Or if you're given points, then you can calculate the slope by finding the difference of y's in the numerator and the difference of x's in the denominator. So have fun practicing with lines.